Welcome to VRAR World, and today I'm at CES together with Dr. Karl Hense Brandenburg, from Brandenburg Labs.
Perhaps known the name from earlier work long time ago on MP3 and AAC and audio coding, and I've been associated with Fraunhofer quite some time. I thought what to do next. There's some unfinished business, some ideas which have been around for so long and nobody has solved them. So I said, okay, let's try that. Let's start a new company. Let's find some really great young people to help with that and together solve the old problem of how to get natural, plausible sound to headphones. But normally if you have headphones on, the sound is in your head or near your head. Sometimes it moves a little bit if you turn your head, but it's never as realistic as it should be. So we set out to solve that, and we are now be able to prove that we really can do that like nobody else. We try to resolve the word immersive to a sense where you have headphones on, but it feels like the real world. You can't distinguish, is that some real sound playing from a sound source in the room, or is it virtual? So that's what we call immersive. You can be completely immersed in sound and don't realize in terms of augmented reality what is real and what is virtual.
What's the difference between your AR audio system compared to the existing one?
In fact, a lot of people try that and nobody is able to do it that way.
Okay, that's the biggest difference.
With this definition, I think we are the only system worldwide which can do that.
How do you make the sound dynamically to the user's movement, and how does this feature upgrade the user's experience?
In fact, we have two things we are doing which are very important and have been underestimated in earlier times. One thing people have done for some time is to have fast and accurate 6 degrees of freedom head tracking. So not just turning your head and getting that into your system, but really movement in the room as well. And our brain registers the minute changes if we move around, how the sound comes to our ear, and that has to be replicated by the rendering algorithm. And the other part, again, something our brain is very susceptible to. Our brain really takes note of what is the acoustics of the room we are in. And therefore we measure the room acoustics, and then for each position the system calculates how it should sound at our ears in that point of time and at that place.
I see. So how long does it take to do the research and development for this whole system?
So as a professor, I started supervising basic research on these topics something like 13 or 14 years ago. And we have now 3 finalized PhD theses and others working on these topics at the university still. We worked with others and took some ideas from Aalto University in Finland. So some 2 years after we started the company, we've been able to show the first demo. But since then, there have been a lot of little changes. Now, after 4 years, it's better than ever.
Talking about the audio system, what is your market positioning for the Brandenburg Labs, the system, and what is the target audience?
In the end, we want to go to the consumer market. We think this can enable better hearing for all of us, not just for the hard of hearing people, but for everybody. Like there's a lot of people who have glasses. That could be the equivalent of glasses for our ears. Just getting better listening everywhere and in all situations. But of course, that's the long-term vision. First, we go for professional markets. The next, and for that we already need some additional financing. The next step will be to have audio headphones which can be standard headphones which just have to be modified a little bit. It's not that clear what we can take there, but we need sensors to do the tracking on the headphones. And on the other hand, we need to have a wireless connection. In the moment, because the brain recognizes if something is not fast enough in the reaction, in the sound coming back to the ears, we need less than 20 milliseconds of delay between turning the head and the algorithm changing the audio, so it really responds to this turning the head. And that doesn't yet work over wireless connection. So standard Bluetooth is just too slow for that. But there are possibilities. We are looking already into that. So that will be solved quite soon. And then, of course, we have audio systems like for communications, where people could sit around a table, but some of them are really there and the others virtual and can just talk like in the real world. Or audio conferences where you hear the people from different positions, and that makes it easier to really distinguish who is saying what. And so that could be the next step to have these applications. In the long run, we have a vision we call personalized auditory reality. And that means that we have everything in the headphone fully adaptive. So the headphone adapts itself to where it is. It continually measures the room acoustics or get information about the room acoustics from environmental noises and so on. And that allows us to be somewhere and have AI-supported intelligent processing in the headphones, like doing adaptive noise cancellation only for certain sources, where there's too much noise, you want to get some noise reduced, you want to listen to the people in the same room you normally couldn't understand, or you would like to have somebody on the phone, but not speaking inside your head, but really standing next to you. And of course, you can combine that with other technologies. Once people get real-time translation capabilities, we could have a system which translates from a different language to you.
Oh,
I see. Still like the same person speaking, but just it looks like this person suddenly speaks your language.
That's fantastic. It will works very well for the conference. If someone is speaking like English on the stage, and then what I hear is like the same person speaking Chinese.
Exactly. Yeah. That's not our topic. We just enable such solutions.
And talking about the multi-channel audio system, could you tell us a little bit more about that one?
In fact, here at CES, we demonstrate such a system for the first time to the public. And this really can recreate a whole room of loudspeakers so that it sounds like these real loudspeakers would be in the room. And that's what a lot of people look forward in the professional case at the moment, like mixing studios who want to test their multi-channel mixes. But it could be interesting at home as well. Have your movies together with great sound, but you are not allowed to play it loud over loudspeakers, or you don't have the loudspeaker system. Then you can use these headphones and get a much more immersive sound than ever before. The special feature here for the multi-speaker setup is that you have not just a few sound sources, but you can really have many sound sources, and you hear them like they would be real. You could even listen to a jazz combo in your room and hear where the instruments are and who plays what and so on.
欢迎关注 VRAR 星球。